All right, so some more examples of graphing rational functions. Starting here with number 2, again, remember my first step is to simplify. So in the top and the bottom, I have a binomial, which means I'm just going to pull out my greatest common factor. So in the top, my greatest common factor is 4. And when I factor out a 4, I'm left with x minus 6. And in the bottom, my greatest common factor is 2. So I can pull out 2 and I'm left with x minus 2. So I have 4 over 2, and that can simplify to be 2 over 1. So my simplified function is 2 times x minus 6 over x minus 2. There's my simplified function. Step 2, find the x-intercept by setting the numerator equal to 0. So if I set 2 times x minus 6 equal to 0, and I divide by 2 to get rid of the 2, and I'm just left with x minus 6 equals 0. Move my 6 over, and I get x equals 6. So my x-intercept is 6, 0, and I'm going to go ahead and plot that. 1, 2, 3, 4, 5, 6. Okay, next I want to find my vertical asymptote by setting the denominator equal to 0. So my denominator is x minus 2. When I set that equal to 0, I just move the 2 over and I get 2. My vertical asymptote is x equals 2. So I'm going to go ahead and draw that in as best I can. Okay, that was step 3. Step 4 is to find the horizontal asymptote. Now remember, our horizontal asymptote is based on those 3 rules depending on my exponents in the top and the bottom. So in the top and the bottom, they both just have an exponent of 1. So that means they're equal to each other. My degrees are equal to each other. So I divide my leading coefficients. So for step 4, y is going to be equal to 4 divided by 2, which of course is equal to just 2. I apologize for my dog having a spaz attack back there. So my horizontal asymptote is at y equals 2. All right, next I need to find a whole. And here my whole is just a common factor. And the only common factor they share is 2. So there's not going to be a whole. All right, so now we want to know what this graph looks like. So I'm going to pull up Desmos and I type in my function and it shows me I have those 2 curves like so. So I'm just going to graph that in the same way it was in Desmos. And then I can talk about my domain and range. Remember, domain is our x values, and x is restricted by our vertical asymptote at 2. So x cannot be 2. And then our range is our y values, and that's restricted by our horizontal asymptote, which is also at 2. So y cannot be 2. So that concludes example number 2. Now I also want to work example 5. So let's go down to number 5. And again, following the same steps. Step 1 is going to be to simplify. So in the top and the bottom, so in the top I have a binomial, so I'm going to pull out my greatest common factor, which is x, and I'm left with x plus 4. In the bottom I have a trinomial, so I'm going to use double parentheses. And so I have negative 4 on the outside and plus 3 on the inside. So I need factors of negative 4 that add to 3. And so that's going to be positive 4 and negative 1. Now I can cancel the common factor of x plus 4. And I'm left with my simplified function of x over x minus 1. That's my simplified function. Step 2, I want to find the x-intercept. So I set the numerator equal to 0. Well, if x is equal to 0, then x is equal to 0. So my x-intercept for number 5 is 0, 0. So I'll go ahead and plot that, 0, 0. All right, step 3, vertical asymptote. I set the bottom equal to 0. So if I set x minus 1 equal to 0 and I move the 1 over, I get x equals 1. So my vertical asymptote is x equals 1. Go ahead and plot that. All right, next, vertical asymptote, or sorry, no, horizontal asymptote. And remember, we look at our exponents to determine that. And if I go back to my original function, I have x squared in the top and the bottom, which means my degree. So my biggest degree is squared and squared. So I'm going to divide my coefficients, and they're both a coefficient of 1. So y is equal to 1 over 1, which of course is just 1. So my horizontal asymptote is at y equals 1. All right, whole. Remember, a whole exists where they have a common factor. And I'm going to just erase some of this to give us more room to work. So their common factor was x plus 4. So remember, first we find the x value by setting the common factor equal to 0. So my common factor of x plus 4, I'm going to set that equal to 0. And when I move the 4 over, I get x equals negative 4. So that's my x value of my whole. Then I find my y value by substituting the x coordinate into this simplified function. So my simplified function, remember, is x over x minus 1. So I'm going to plug in negative 4 to that function, and I'm going to get negative 4 over negative 5, which is 4 over 5, because I have a negative divided by a negative. And that's my y value. So my whole is at negative 4 over 5. That is where I have my whole. And so I'm going to draw that in, negative 1, 2, 3, 4. And I'll just do a little estimating. And there's my whole. Now, again, I want to know how this looks on the graph. So I'm going to go to Desmos. Where did Desmos go? There it is. And here is my graph. So I'm going to graph it just like it shows on there. And here is my function. So domain, remember my x values. My x values are restricted by our vertical asymptote, which was at was at 1. So x cannot be 1. And it's also restricted at my whole, and that was at where x is negative 4. So x cannot be 1 or negative 4. Now my y values, remember, the range, the y values are restricted by the horizontal asymptote, and that was at 1. So y cannot be 1. And it's also restricted at my whole, and the y value at the whole was 4 over 5. So y can also not be 4 over 5. And that takes care of example number 5.